What I'm going to show you is if you have a platform that is built for full auditability, that has the system of git-for-data and is built for kind of like rewards isolation and being pedantic, you actually can use an AI system to automate a good deal of the work that your data engineering team, not only your data analyst, your data engineering team is doing today. Without further ado, for this demo, we're going to just like use Claude Code. I'm sure that most of the folks will be familiar with that at this time. But the real, like the situation that we find ourselves should be something like this. You have a, you might, I'm sorry, this is, your initial situation would be something like this, where you actually have a bunch of things in your data platform that didn't go well. So imagine that one of these is a pipeline, a transformation pipeline that takes some raw data, transforms the data into a table that is consumed by a downstream users or application, and that this pipeline failed. It failed during the night, maybe failed while a certain job was running on a schedule. The job of a data engineer today would be to go here and fix it and understand what went wrong, if it is a problem of the data, if it is a problem of the code, if it is a problem of the infrastructure. What we aim at doing is automating a part of this. So for instance, I can go in a place like a Claude Code and say, hey man, can you tell me what jobs failed in the last, I don't know, 5 hours. What the system then will do is that we have an AI agent, in this case, Claude, that interfaces with the data platform, with the data stack using an MCP server. And because everything is exposed as code, it's particularly simple to do that. So you have something like this, just like, well, in the last 5 hours, this is what happened. It's like, okay, so can you tell me what went wrong there, and do a quick root cause analysis. Make sure to include your suggestion about what to do. With the same logic, now all the APIs of the platform can be explored with the MCP. So now the agent can do and just like get all the metadata of the files of the tables, run queries potentially inside of the tables to see what went wrong, scan through the logs of the system that are also exposed as a Python API, and understand, like in the scenario that I was mentioning before, what exactly should be done, because it can be in principle a problem of data or the code or the environment or all of them. Like it's an undetermined problem when we see just a pipeline failing. You don't necessarily know what happens. Okay. So in this case, probably what went wrong here is going to be a mix of data and infrastructure. Knowing these jobs, as you can see, we have already our first report that says like, well, there's a problem with the environment. So it appears that we have some Python and pandas and NumPy compatibility problems. So there's a function somewhere that is not running correctly because of this. There's another case where there's actually a problem with our data modeling. There's a column that is missing. So the recommendation is to fix this in a certain way. Now the question is, as I was mentioning before, can I have the agent actually fix this? Like, this is very nice, and it's already, you can think of this like this is a demo pipeline that is like fairly simple, but you can think of this like on a most gnarly and complicated pipeline. This is already saving you hours of your time that otherwise you would invest in digging into the logs and do all this by yourself. But the real deal is, okay, can you fix it for me? Because, it's great to know what went wrong, but I actually would like to have, this thing fixed. So that's what we're going to do. Let's take like let's take one of them. Okay. So for instance, you have first one here, and say, can you help me fix this job right here? I want you, and this is where the ergonomics of the platform comes in, because we're going to ask the system to open a branch, to open a data branch, and change the pipeline, run it. And when you think you have figured it out, write a report and give me back the branch so I can take a look at it and merge it. This is only possible because there is the git-for-data abstraction in the background. It's the only possible because otherwise I would be very nervous about an agent changing some code in a pipeline and running a pipeline in my production environment, as that would change effectively the status of a table or will change, the behavior of downstream applications. And if I don't have a quick and simple way to isolate the agent while it does this, or a way to roll back, in both cases, I would be extremely nervous. Like if you think about it, one of the reasons why code generation is so popular. Okay, it's already fixed those, identified the problem. One of the reasons why code agents are so popular when you do code generation is that you can roll back. You have Git. So even, besides the horror stories that you read on Twitter, of people having, cursor doing something terrible to their application. But generally speaking, is a reasonably safe environment where you can guardrail the agent enough when he just writes code. When he writes something like a data table in your application, it's a completely different ballgame. And so I think it's an interesting point that the combination of this data branching system, which creates this new branch here, is fixed NumPy compatibility. Okay. And then just changes the code. And is actually able to run a project from scratch and create new tables now. And finally, give me a report with my new pipeline. This is what happens. It seems that it ran correctly. But now I do have fundamentally a branch that I can check out to. If I switch to my terminal, what I will do is I'm going to check out to this branch. And now I can explore the branch and see what are the tables that were created by the agent and see potentially explore the data myself, understand what's right, what's wrong. And if I'm okay, I'm going to merge this table now back into main. Sorry. No, this is my.
No, it's not the right branch, I think.
It's not even a branch. This is
you put the table instead. Yeah, it's the table name instead of the branch name.
The table name. There you go. Okay. So now we should have our fantastic new table, which is called top pickup location. Get. There you go. So we have it in main. So all the work that would have been done by a person, the bulk of it has been automated by a system. And for the purpose of this demo, we like to show this as an interactive flow using Claude code, where you can chat with it. But this is ultimately an AI system. The important thing here is that you have an AI system that can access fully a data platform that is designed to be kind of AI ready because it's API first and code first. It's very easy to think of this system as a system that now just runs asynchronously. So instead of having my terminal and do this myself, I have a bunch of prompts and I just have an agent that wakes up whenever there's a problem. And so instead of waking up in the morning with a bunch of failed jobs and, little indication of what happens, what you will have is a bunch of failed jobs and a bunch of attempts to fixing these jobs by an agent. And so my job now is to review the work that the agent did while I was sleeping instead of doing something else. The example here would be, if we take another job, for instance, right? You have, it will look like this, right? You will have automated systems coming to me with a job that's completed, and I can then inspect the job and say, it's okay, so this is what the agent did. This is the logs, this is the code, and these are the branches. In this case, it's this job ran on main, for instance. This is the branch where I should check it. But your work changes pretty radically in that sense. You become more able to you can do much more just managing the swarm of little agents helping out rather than doing this yourself.